Hello. Um, I wanted to create a small video, well, this video, to show you a little bit of on Wireshark. There is a link on your Blackboard that shows a few links on YouTube of people showing how Wireshark works and what it is and how to use it. Um, your first assignment is on Wireshark. So since some people are kind of eager to jump into it, that's what I wanted to give you like a head start to those. For those that are not ready for it, you just wait a couple of weeks until we start getting more of the material, more into the chapters, and you will be able to understand the whole thing with Wireshark. Wireshark, it's a packet capture software. What it means is that it would listen on your network card and capture every packet that goes through that connection. Remember that packets is a layer 3, right? Um, Remember what I mentioned, the sunscreen, SPF, segments, packets, and frames. Segments is on layer 4. That's where your segmentation happens. If your payload is too big to be able to be handled through the that communication, it can be segmented into smaller packets, into smaller segments. And then you got packets on layer 3, and then you got your frames on layer 2. Now, your connection from your computer to your router is usually at, to a switch. That's a layer 2, but remember that once you get to layer 2, that means that you pass through all the upper layers in order to get to layer 2. So that's why Wireshark is able to get everything from layer 3, layer 4, all the way to the top, because you already go into layer 2, and your network card is going to send everything through the wire at a layer 1. So Wireshark can actually get that down to to the bits and bytes on your wire or your wireless. The first thing you need to do is to download the application. The application is from wireshark.org. When you go there, you can click on download. And on download, what you want is your Windows 64-bit installer. Not a lot of people are using Windows 32-bit. In case you need it, you can use that. But I'll say like 99% of the people right now are using 64-bit. If you are a Mac user, they have the Mac application for it, so you can download the file and do the installation. When you download the file, then of course you just need to run it. I already have it, so, but I'm going to go through the motions. I'm going to go to my downloads. Here's in my file. So I'm going to click on it, install it. Well, this one says that I already have it, so you want to uninstall the first one, but it will go through the motions just like you were doing. So we click next. Noted. Yes, I want everything. Here, by default, it doesn't have the desktop item. The desktop icon. You want that. I mean, it's nice to have it. I like to have it there. It's default directory. Here, I already have the npcap 1.0. So in your case, you'll have to, it will probably be already selected to install. So it will install it. The USB pickup, that's in case that your network card is going to get through a USB port. Some of the new laptops or even some of the new Macs don't have a wire network card installed hardware wise on the computer. So you have to use a one of those USB adapters that goes to a wire Ethernet connection. So if that's your case, then you will need this. If not, just leave it like that. Mine is it's a desk. Well, this is a laptop, but the laptop has a wire connection. Okay. So while this is installing, just remember that we're going to capture everything. Everything goes from layer 1 all the way to not to layer 7, because that's the when you present it to the user, but to the layer 4, layer 5 layers, encryption and all that. Everything there can be captured by this software. The installation is pretty fast. As you see, my icon is already there. And it is done. Next and finish. So double click on it. If you don't know exactly where it is, you can go to the search and you go wire and it comes up right there. Open it up. and that's your Wireshark. Now, Wireshark will present you to all the network cards that it finds on your computer. My laptop in this case has a whole bunch of connection 9, wireless connection, local area, connection 11, connection 10, the Bluetooth, all that, you name all that. But you see this one? See how it sees something? So right now at this moment, Wireshark is seeing activity there. So that's usually my main network card that I'm using to communicate on this computer. All the other ones are quiet, so they're not showing anything. So that's the one that you want to capture. To start capture, super simple. You go to capture, you go start, and boom, there it is. Even though I'm not doing much on the computers, you'll be surprised of how much work the computers do in the background without you knowing it, and updates and checks and this and that, and checking for updates in your computer, checking for any application, checking for your email, checking for anything that is open there. So it's amazing you see see all of this in there. Um, so one more thing. You need to find out which is your IP address. What is it that you're sending from? On Windows, it's quite simple. Windows, you come to the search and you go CMD. That will open a command. It will bring up command application. Click on it. It opens a Windows command prompt window, right? So I'm there. For Windows, if I want to know my IP address, there's a command called ipconfig, like configuration, but you just cut it short. Hit enter, and there you go. So my Ethernet adapter, it is on 172.20.10.6. Keep that in mind because your IP address is one that you need for tracking. It provides you with the subnet mask, and it provides you with the default gateway. The default gateway, remember, is the router that when you want to communicate outside your local LAN, it has to go through that door to communicate to the outside. So this is it's pointing me where the door is, and that router is responding on that IP address. Okay. There's some applications on Windows for testing. One of them is Ping, P-I-N-G. Remember in the old days, or not the old days, even now, on the submarine movies that they tell you, they said, send one ping or send two pings. What they would do, the sonar will send one ping, the sound of or one ping. It will propagate through the ocean. It will hit something, and when it comes back, they measure that timing of how long it took to get there and come back, and they start comparing and see if you're getting closer or further away from that object. So computers uses a little utility called ping that you can actually do that. So let me pick any address, like one of the known IP addresses for that two. And what this thing does is that it will send 32 bytes of data to 4.2.2.2, and then I got a reply. This is a reply back from them, and it took 14 milliseconds. So this is a good utility also to find out if my connection to something is kind of far, or is slow, or how long does it take for me to get there and come back. Okay, we'll get more into this. Another thing is the TTL here. So TTL is time to live. Time to live is a counter. Time to live is a counter that every time you pass one router to another router to another router to reach your destination, it will decrement one count. And one count, one count, one count. What this one means is that my TTL right now is 56. That means I don't know what was the original. It's not shown here, but those every time I hit a router, I went to another provider, another provider. It got decremented all the way to 56. If your TTL is too low, and which you can do that, make a low TTL. So that means that when it goes to a certain distance, you cannot get past that, because once the TTL goes to 0, the packet expires and it gets dropped. So if I want to keep something with the United States, I'll probably lower my TTL, because if I want to go to Russia or China, of course, it has to go through more routers and more hopping around, and every hop is one time use. And so that time to live gets expired, gets decremented until it ends. So now you see that you can send information. This is my IP config. If you're using a Mac, there's two ways to get your IP address. You can go into your Mac and go into your, I'm not a Mac person, but you can go into applications, utilities, and then open terminal. Once you're in terminal, the command you want to use there, it's ifconfig. Not IP, you use ifconfig. And that's the command on Mac, and the Mac will give you the IP address that your computer is using. Or you can go through your Finder, System Preference, Networks, and then you'll see your Ethernet or your wireless, the Wi-Fi. You pick one of those, and that one also gives you your IP address. It doesn't say default gateway, that the Mac says router, and it would also show you your DNS servers. If you want to get your MAC address, which is more like the layer 2 address, on the Mac, you click on Advanced on that Ethernet connection, Ethernet window, and at the bottom, it will show you the MAC address. On Windows, it's quite simple. On Windows, if I go again, ifconfig, ipconfig, it gives me this. If I go ipconfig slash question mark, it gives me all the options that you can do. With the second one there, you see that it says slash all. So that gives me all the information. And so here it tells me that this is my, here, my IP address, my subnet mask, my default gateway, my DHCP server, this is who handed out the IP address to me, and my DNS servers, right? DNS is dynamic name system. Dynamic name system is a way for the computers to translate between names to a real IP address. All the systems on the internet, they work with IP addresses. The names are assigned names. You can have an IP address and assign it today www.google.com, and if you want to change it tomorrow to www.pepsi.com, you can do that to the same IP address. It's just that when you look for it, it has to resolve. It's called a DNS resolve to that IP address, right? So everything has a specific IP address, and the name is assigned by DNS servers. So DNS server is kind of like a phone book. You remember that in the old days with a phone book? Well, even though you're not the paper phone books, but now on your phone book, if you want to call Juan, you look for Juan and you hit Juan, and he calls. Well, he's not calling the name Juan. It's the phone book is doing the translation between the name associated to a specific phone number, and then it will dial the phone number. Now you don't. In the old days, you had to remember the phone numbers for everybody. Now with all these smartphones, you don't have to anymore. You just go through your phone book, click the person, and that will dial that number. If that person changes number, what happens? You keep the same name. All you do is change the phone number, right? Same one, but it's just a different phone number. So that's the same thing with DNS. If at any point Google.com wants to change the servers to another IP address or move it to another location that has to have a different IP address, all they do is they go to those directory services, the DNS, and change it there. So when you query, hey, what's the IP address for www.google.com, it will reply with the correct IP address. Okay, this is a lesson on DNS now. But anyway, that's what happens. It's just exactly like that. That you don't go by names, you go by IP addresses. So that's important to have, to know that. Anyway, so and we'll get to a point because of that. So this is your Wireshark. Now Wireshark is always doing something. Like when you're pinging or you're doing anything, whatever. If you see this here, it says apply a filter. These filters here there are thousands of commutations of filters that you can do here. I don't know much of them, to be honest. I just know the basics, right? So remember that I just did a ping to, it was here. I did a ping to 4.2.2.2.2. Since I'm still capturing all of that, I'm going to say, okay, give me the packets that the IP address, which is ip.addr, and I can do two things. I can do equals, and then, notice that the bar is pink. That means that the command is not fully done. It doesn't understand what you're doing. So 4.2.2.2, and it turns green, says, oh, now it makes sense to me that you can do something. At this point, there's two things you can do. You can hit enter, and it will take it. Or if you look at the right, see how the arrow is blue? This arrow in the corner? So you can hit that, and it would apply the filter. So now, even though I had thousands of packets being displayed on the screen, my filter is just filtering anything that has IP address. Now, on these filters, there's two ways to display them. A IP address is a filter that doesn't care if it's a source or a destination, because here, see that 4.2.2 is a destination, and here is a source, and here's a destination, here's a source. So you can actually change this, and I go IP that SRC for source, see, turn green. I'm going to hit enter. So now all I see is all the captured packets that is the source is 4.2.2.2. Or I can change that SRC to DST for destination. And then I have 4.2.2.2. Now, another thing that is kind of cool to use, that you don't have to use equals. You can actually do EQ, and it's the same thing. So I can do IP destination equals 4.2.2.2, and I can also do the OR command. I said OR IP that source equals 4.2.2.2. And that worked just like the other one that we put before. The IP address, something equals something. When you put IP address, he will capture everything for source and destination. Here you can do, display my source, or if it's a destination, they are the same. Right? They use the same result. So if you see this window here, look how cool. I did a ping, and if you look back here, it did 1, 2, 3, 4 pings, right? So all my capture that has is one that I send to 4.2, and 4.2 reply to me. And you see here's a request and a reply. And then I send a second one, request, and 4.2 did a reply. And then I send a request, and then I got a reply, send a request, got a reply. 1, 2, 3, 4. Exactly like we did here. Not one more, not one less. Everything got captured. More things that you can do here. See, Wireshark has two windows. The upper window is the one that shows all your packets and some information, what's in there. And then the bottom window. The bottom window is actually breaking down every single packet of this into all the information I can get out of it. If you see here in frame, this is more like your layer 1. This is where all your bits and bytes, and it will tell you your frame length number. It was 9756. The length is 74 bytes. The capture length is 74 bytes. The frame marking NOR is false. A coloring rules for ICMP. ICMP is for pings. I like that. So that's my layer 1. The first chevron here. My second chevron here is my layer 2. And what do you see on layer 2? MAC addresses, right? So here you go. My source, my destination MAC address is here. That's the MAC address of that 4.2.2.2. And then here is my source with address 84 AF blah 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 6264. Is that true? Well, let's see. Remember that I did here a IP config all. Yeah, here. When I did the IP config all, it gave me all this information, and it says, hey, your Ethernet adapter local area connection that has IP address 172.20.10.6. The physical address or the MAC address is 84 8F69 B2 6264, which it matches here. That was my source, 84 AF69 B2 6264. So yeah, that was my computer, this computer generating that traffic, and that's my IP address. So everything matches. Everything matches because it's capturing all your traffic. So layer 2, right? So what do you get in layer 3? IP addresses. So in here, I got information for the IP level, the Internet Protocol version 4, so IPv4. My source was me, 172.20.10.6. My destination was 4.2.2.2.2. Okay. There's some information there for the flags. There's a whole bunch of things. We'll get into that. Differentiated services is for priority. Right now it's set to 0, so it has no priority, just like a normal traffic. Voice and video and stuff like that might have a different preference, but on this one, it just set to that. That was layer 3. And then on this one is the ICMP. It's a very low protocol. So it's using ping, and it has some sequence numbers, right? Sequence number BE, sequence number LE is 5859, and then my data was 32 bytes. Does it look familiar? Well, when I did my ping, what did you tell me they were sending? 32 bytes, right? So those 32 bytes of kind of like junk data, basically. They're right here. This is my 32 bytes of data that you just sent to them, and just to wait for a reply back. So everything that you can get, actually Wireshark, believe it or not, won't believe it, you can capture all the conversation on a phone communication. And when they initiate, they do the encryption handshake. If you capture everything on that communication and you capture that encryption key, you can take all those packets from the source to destination, from the source IP phone to destination IP phone, look at all those packets, insert that encryption key in there, and listen to the conversation with no problems at all. I don't remember exactly how to do it, but I've seen other engineers doing it, people that know Wireshark more on a daily basis, stuff like that. But you can actually decrypt that and see everything that goes inside, and you can actually listen to this, because this is a capture. It's recording everything, even your payload. All the payload that goes through it is being recorded here. Okay, well, so that's how this thing works. You can do more stuff. Let me see here. Remember with the DNS? Okay, come on. Oops, way too far. With the DNS, when I do a ping, I can do ping directly to the IP address, or I can ping a name, www.google.com. And then what my computer needs to do is basically say, well, I need to ping an IP address, not a name. So it has to go to DNS and get a translation. So Google says, it finds that google.com is 172.217.1068, and then you did the pings to it, right? So the computer needs to be doing that. How can I find that? Let's see. Well, we need to find its DNS. Remember that DNS, all of these protocols use a specific port number. Well, port number for DNS is 53. So let's find out all the traffic that uses, let me see. I don't know if you'll find it TCP or UDP, but let's say TCP port was 53. Okay, so let's try UDP. It did UDP. Perfect. So now we have all the DNS traffic. Now, where is my computer going for DNS? This is my source, right? 172.20.10.6. And look where it's going. 66.28.045. Why? Well, because when I do my ipconfig /all, look what my DNSs are. This configuration says that my computer is using as a DNS server 66.28.045 and 66.28.061, which are my ISP provider recommended their own recommended DNS servers. So my computer uses those two only first, and it says, hey, here I'm doing this is a layer 1, this is a layer 2, it's going to that destination IP address, right? The layer 3. Right, the time to live is 128. Look at this, the 128, right? Now at a higher level, remember that the TCP IP was after layer 3, you got a layer 4 where you got your TCP IP. Your TCP, the transport. On your transport layer, now this is where ports are, and then my source port is a random port, but my destination port here it is 53. That's why the filter caught it, because it's destination port 53, and then here again destination port 53. Now, is it using UDP or TCP? Well, it tells you right here, user datagram protocol. So it's UDP. And then if you look at the query, this is the query that it did. And let's look at the queries. And it goes, hey, I'm looking for the IP address for www.google.com, and it's a type A, which is a record. We'll get into that later. And that's the request. So if this is the request, ooh, what was it where I had it highlighted? Let me come back here. Because I think I had it on the screen and I just, is the one that, oh, there's the one highlighted, duh. Okay, so right afterwards, it's the response. And this, it says a standard query response, right? No error. And then when I see that was a query, right? So this is my reply. Now I get another line here that says answer. Well, there's the answer. My www.google.com type A record, it maps to an address of 172.217.1068. That's why ping is able to translate the name to this IP address, and then it was able to do the ping. Interesting, huh? Now there's a lot more information here, because when I went to get that information, the authoritative name servers, the ones that actually providing that information to me, are these 4 servers: ns1.google.com, ns2, ns3, and ns4.google.com. So that's the because we'll get into that more detail into that. But DNS is a distributed database, not one single system will have the whole DNS table for the internet. Is impossible. It has to be, thousands or millions of records. So Google holds all the DNS records for Google. Miami-Dade holds a DNS server that is published, to public access to the outside, to say, hey, if you want to query any name for Miami-Dade, any mdc.edu, then come to me and I'll tell you what the IP address is. So this was, this request went to google.com and he got all of this. So let me see additional records. Hey, there's the IP addresses of those DNS servers. And also, I guess this is the IPv6, the quad A, what is called the quad A record. This is a type A record, which is an IP address, and the quad AAAA is the IPv6. We'll get into that. I mean, if you hear terms that you're not used to, don't know what it is, don't worry about it. We'll get to that in the next chapter. So this is already too early in class to be talking about this. But again, this is for students that wants to get ahead a little bit. So, but anyway, in a nutshell, that's what Wireshark will do for you, and you can see everything. If I open a browser and I go to, actually, let me do this first, because this thing is getting large. So I can do a capture and go stop it, and then I start it again. And I said, you want to continue without saving? Sure, because otherwise you'll save that other capture, which is kind of cool, because you can save those files, send it to someone, they can open the packets, the file, and take a look at all the capture that you did. So if you do that for troubleshooting. So let me get rid of my filter. Why? So you see everything. So anyway, let me do it again. I can stop it here too, and I can start capturing. There are 2 ways. So I can go do it through here, cancel, or I can do through the capture, start, stop, or just like, defend here, or the red button. So let me go with defend, continue. So what I'm going to do now, I'm going to go to my browser. I'm going to say, oh, you know what? Let me go to my website, www.sanchezsite.com. There's not much in there, but I do have a website. I got it just because I can get my own email address. So that's my website. So what I'm going to do here is actually going to capture, stop it. I don't want to capture anymore. And then let's look at again to the UDP port equals 53. And I'll show you something interesting. Again, the browser doesn't know what this name really means. what IP address needs to be going to. So if I go here and I go ping www.sanchezsite.com is 172. Actually, I'm going to write it down on a piece of paper that I have here. 172.67.143.3. Okay, so that's the IP address for that website. Let me minimize this. So when I go to UDP port equals 53, you see a detected portal Firefox, and that's it. I don't see a request for www.sanchezsite.com. So you'll be like, so how does he know it? Well, let's change this from UDP TC 53. No, didn't get it. Try again. It's using a different here. Address. Okay, detected queries. No, actually, let me look at all the packets and see if I can identify where did it go. So let's see, you see how this thing changes colors? So you'll see also the communication to the website, which is, it was 172 something, 67. Okay, actually, it should be this, 104. Why this thing gave me www.sanchezsite.com? Okay. So you see this. This is a now a TLS, a encrypted communication, right? That's going to the website. But let me go back here. Never advertisement. Okay, this is some retransmissions. Kind of lost it. This is an ARP advertisement. Try to find where did he get the IP address from, because this is 67.143.3. There it is. So this is communicating already to the website. Now, if you see my website, you see how this has the padlock and it's using HTTPS, right? So HTTPS, it uses port 443. Remember we talked about ports before and all that? Well, it uses 443. So if you see here on my TCP, now it doesn't say UDP, it says TCP, and it's using port 443. And that was communication between my source, which is my computer, to the destination. That's the website. So it's asking something to the website over 443, right? And this is all the payload and everything in there. So I don't know what communication is actually going in there. Oops. So you request data, application data, and then this is a reply. And I got another reply. So now I'm getting more data from the website. It's also using TCP port 443. See how things change? And also when you start breaking this down, see now, remember the layer 1, layer 2, layer 3, this is your transport. This is the transport layer security. This is more into the session layer where you can actually do your encryption. See, this is your TCP UDP ports. And then here is your encryption. This is where all encrypted application data. See, that's at a higher level, a higher layer. So this is the transport layer security. Well, it doesn't match with the transport layer of the OSI, but this is your more like your layer 5 of the OSI, where you do the encryption. So all that data, I cannot see it because it's encrypted between these two endpoints, my server, the web server, and my computer. So this is more communication, right? Let me see. I was going to show you. Application data. I'm showing everything. Okay. A workstation. See this, look at all the traffic that happens on your computer. You know, it's amazing, all the things that we'll get later into this acknowledge and push and acknowledgements, how that works. It's just for secure communication. This is more like TCP saying, yes, I got a message, or retransmission saying, no, I didn't get it, so please send it again. So see, this is a retransmission, this is an error. So the computers can like realign themselves. Okay. Anyway, so this is in a nutshell how Wireshark would work, and the assignment will be something like this. So you're going to have to be looking at some traffic, put some filters, and then find that, find what happened there. Like, I don't know, like I said, TCP4 equals 53, apply it, and then, no, TCP, UDP. Okay, UDP, like that. This is, yeah, this was going to AWS, Mozilla AWS, answered, detect portal. This is Kaseya, this is Miami-Dade. See, kaseya.mdc.edu, response, DOH, queries. And it was a DOH test. But anyway, so that's what you'll be doing on that. But Wireshark is a great tool. If you really want to sometimes find problems of communication, this is your tool. This is that will show you every communication, all the handshake between two devices, and see how things actually work or didn't work. Again, let me see if I do. Again, if I use some IP address. So this is source or destination, right? Equals my IP address. It is 172.20.10.6. Let me do or IP at this IP data address. Remember, it's like similar to say use that as find it as a source or as a destination. Equals 172.67.143. I have it. That's the one I wrote down. That's the website. There you go. So this is all the communication between my computer and the website. Oh, this is something. Oh no, it's showing everything that is sourced from here. So let me just do this. Just the there you go. So that's, see, this is showing as a source or destination. So this is the whole communication between my computer and that website. This red could be as an, like, I think usually it does have errors. So something happened here. See, reset acknowledge, reset. That's a reset. And then here you go, more TCP, TCP retransmission, something fell at the end. But everything is here. What version is he using? TLS version 1.3. And that TLS is the transport layer security, and is version 1.3. So that means that my website is actually using one of the new protocols, not the 1.2 or the 1.1 or 1.0 that is already deprecated. So that's it. So keep an eye on the assignment. You'll see it. I'm going to post the assignment, and you can go through this video just to give you a heads up on that. If you have any question, you can always email me. You can always call me. We can do a WebEx. We can do a Teams. I can log into your computer and then see what you're doing and help you with that. But I'll leave you here for now. This is I took about 40 minutes of your time, so I appreciate if you listen to my small talk. All right. Thank you, guys.